Okay, so I think let's start with the session. So hello everyone. So welcome to the Kotlin Multiplatform and Compose Multiplatform session. So in this session, we will be talking about what is Kotlin Multiplatform, how you can start with, and how is the ecosystem. And then we will also cover Compose Multiplatform and what it is. But before that, some info about me. So my name is Abdul Basit, and I'm a software engineer and also an Android GDE. And I also have like experience with Java Spring Boot. So when we say multi-platform, so from multi-platform, we say that we mean that write once and run everywhere. So multi-platform means that you write a single piece of code, and that single piece of code runs everywhere on every platform. So you might have heard some about the famous multi-platform frameworks. So Flutter is also like a multi-platform framework where you write code in Dart language, and then that Flutter app compiles into Android, iOS, web, and desktop, and you can develop Mac OS systems, the apps, and also Windows application. Then we have React Native, which is based on JavaScript, and in React Native you can also develop application, and then React Native also have some other frameworks like Electron, and which with JavaScript you can develop desktop application. But if you look into these multi-platform applications, so the issue with that is that they are not native. So now native is subjective. So some people say that native means like if the UI widgets they are same to same as in native, so that means that it is native. So if you look the navigation system in iOS and iOS, so that is a bit of different, and also the widgets, the text, and each and everything is different. So if the UI is same, that means that they are native, and if the UI is not same, they are not native. And another perspective is that if the code that you are writing, if they are in the same memory address, so that means that they are native. So in case of Flutter or React Native, so how they work is that there is a bridge between the native and the framework code, which is like getting called, and based on that, this is how they work. So the memory address is not shared in case of the Flutter or React Native, but then we have Kotlin multi-platform. So in case of the Kotlin multi-platform, the codes convert into native code. So suppose if I give you an example of the Android and iOS, so Kotlin is native for Android, but for iOS, the Kotlin code compiles into Objective C code. So the code of the Kotlin multi-platform or the files that are created, so they are in the same memory address. And another benefit with the Kotlin multi-platform is that like you can share as much or as less as you want. So you might have seen that if you are developing an application in Flutter, so it gets kind of a bit difficult uh, to uh, communicate with the native APIs, or like you are totally in or totally out, like from the Flutter. So it's like a bit of difficult to use the Kotlin code. Like it is possible, but as comparatively to the Kotlin multi-platform, so it is a bit difficult. And the same is for the React Native. But with the Kotlin multi-platform, you can share as much or as this as you want. So suppose if you have an existing application and you want to start experimenting with that, so you can have the events converted into the KMP that could be called from the Android and iOS. And you could also convert your network layer or the DB layer to the Kotlin multi-platform. So you can share like is less as you want, like just some specific part of the code, or you can develop the whole application on Kotlin multi-platform. So now that was a bit info about the Kotlin multi-platform. Now, if you want to start with the KMP, so you have to set up your environment. So there are certain steps or certain tools that should be on your system. So first of all, the K-Doctor. So it is a command line tool that would help you to analyze if your environment is ready for the Kotlin multi-platform development or not. So it is available on the GitHub, And once you install that command line tool, so it will be telling you what is your, if your operating system is compatible or not, what is your Java version that you are currently your system is using. You should have Android Studio and Xcode if you are targeting iOS, and then it will also check for the Cocoa Pods. So the Cocoa Pods, they are same as like we have Gradle. So it is for the dependency management. And once all of these are checked, so your system will be ready to do the multi-platform development. Then we have the KMM plugin. So you will be developing your application either in Android Studio or Fleet. So for that, you need to have the Kotlin Multi Mobile plugin that should be enabled, which will help us to support the multi-platform development. So you can like just write the Kotlin Multi-Platform Mobile, and there will be a plugin, and you just have to add that. So once you add that plugin, so it will give you two templates. So if you go to Android Studio and create a new application, so it will give you two, there will be two new templates. So the one is Kotlin Multi-Platform app, and the second one is Kotlin Multi-Platform library. So if you are trying to create a library, you can choose that template, or just want to create a multi-platform, so you can start with that. And it will like create some pre-setup for you instead of like doing each and everything manually. So that was the first way where you can do your uh, you can start or create a project with the Android Studio. But there is also another way, which is the KMP templates. So if you go to kmp.jetbrains.com, so there they have a template where you can where you can target multi-platform, and then you can download the code. So here you can see we have Android, iOS, desktop, web. And if you also want to develop your backend in the Kotlin, so you can also select the server. So once you click on download, so it will give you some predefined a pre-set up environment, like the Compose Multiplatform platform will already be integrated, desktop setup and web setup will already be ready. And you can also go to GitHub. From there you can clone that template and use that. And apart from just the new template, so they also have the template gallery. So if you want to like share the UI in Android and iOS, so you can select that one. Or if you want to keep the UI native but just want to like share the implementation of the network code and data layer, so in that case you can use the native UI platform app. And then we had the library template, which will help you to create a library for multi-platform. And then we also have another template, which is from the Terra. Okay, so it gives you like a diverse option. So you can target Android, iOS, JS, Mac, Linux, Windows, wasm. And it also gives you to include some libraries that support multi-platform. So we have Kotlin coroutine serialization to for the network communication. We have datetime. So if you need to interact with the datetime API, so for that you need that. Then we have Kermit for logging, Skator for the communication, SQL Delight for storing the data locally, and multi-platform settings. So it is same as like the share preferences in Drive, the key pair, the key value data. And then we have built config. So uh, in Android, normally if you are doing a product, if you are doing a staging development or production development, so we use different URLs. So you could also configure that with the built configs. And then we have Coin for the dependency injection, and also KStore. So you can also start with that. And once you check that, so these library will already be included in the template. So now we saw how we can start with the KMP, but in this example, we will be starting with the Android Studio example. So once you create the project with the Android Studio, so you will see there is like a structure. So we have Android app. Here you can see we have the Android app, then we have the shared module, and then we have the iOS app. So the share that is being shared between the Android and iOS. And we have a function called greeting, which could be accessed from the either Android or iOS. So this is how your project would look like. And then here you can see that we have a function which is called git platform. And if we look into that, so the platform that is in an interface which have a name. And then we have a expect function which is called Git platform. So the Kotlin multi-platform works based on the expect and actual functionality. It's like same as interfaces, so we have one interface and we will have multiple implementation or different platforms. So in this case we have an expect function, and now on each platform we have to provide the implementation for that platform. So keep that in mind, that this is when you want to access something that is platform specific. If you don't want something that is platform specific, so in that case you can like just directly call that function, or like the Kotlin native libraries. So we have the Git platform. So here we are looking into the iOS implementation. So we have a class called iOS platform, which is extending the interface that we define. And here we are overriding the name. And in the actual implementation, we are returning the instance of the iOS platform. So as I mentioned, that it is like having interfaces, that you have one interface and you have different implementation of that interface. So this is for the iOS, and yeah, this is for the iOS, and now this is the Android implementation. So we have the platform interface implemented in the Android platform, and here we are returning the name, and then we have the function which is creating instance of that platform. So this is how you work with the expect and actual mechanism in Kotlin multi-platform. And as I mentioned, that with the KMP, you can share as much or as less as you want. So if you want to like just share a piece of code or a piece of logic, you can do that with the KMP. And if you want to keep the UI natives but share the overall logic, so that is also possible. Or if you want to create the UI totally like develop the whole application in Kotlin. So in that case, you have the Compose multi-platform, which is same as Compose, and based on that, you can develop your application in Kotlin and totally in Kotlin multi-platform. So this is the expect actual mechanism. So we have like the Git fun platform, and then based on the actual implementation, so we are providing the implementation for each interface or for each expect function. And so here we are creating a random UUID, which will be in our common code. And now because the random UUID generation is different on each platform, so we will be providing the implementation on each platform. So in Android or the JVM, so we have the UUID dot random UUID dot toString, and on the iOS main we have image UUID dot UUID string. So based on that, the UID will be generated on each platform, and it would be written as a string. Then we have an example. So suppose if you have a greeting class that you want to access, and that we are currently creating like a string. So this is the function that we will be calling from the iOS and Android, from the Swift and from the or Kotlin code on our platform specific. So we have a function for a greet function, which is creating a string, a list of the string. So if the random is Boolean, so it will say true. It true, so it will say hi. Otherwise, it will say hello. And then we will have. Let me check if. Okay, so it will return a list of the strings. Am I audible, Mahmoud?
Yes, we can hear you.
Okay, okay, nice, nice. Hopefully, I'm not wrong. Yeah, okay, nice. So here we in the greeting function, so we are returning a list of the strings. So now, if you want to call that greeting function from the different platforms, so this is how you will be doing that. So in case of the Android, so because the we have the Compose, so we will have a material theme, and then we'll create the instance of the greet. We create instance, and in the greeting, so we will get the list of the string, and then we can have a for each and text and divider. So this is how it will look like. Hello, guess what it is? Android 34. Now, if I want to call that from the Swift, so in that case, because the as I mentioned that the Kotlin code is being converted into Objective C on the iOS side, so we can also access that So we have content view, and inside that we will create an instance of the greeting, and then we will call the greet function, which will return a list of the string. And then in the body, so we have a list, and for each we are having a text. So this is how it would look like. Guess what it is? iOS. So this is how you can call your Kotlin function from the Swift and from the Android. Now, if we talk about the ecosystem, so we saw that the Kotlin multi-platform is very versatile, and we have a lot of functionalities that we could do with, and it's very flexible. But how is the ecosystem? Like, what are different libraries that are available, and what we can do? So the ecosystem, it is like getting bigger and bigger day by day. I think there was some stat that around 2000 libraries were created for the Kotlin multi-platform. And we also have a repository, KMP awesome. So in that we have a list of the uh, different functionalities like networking, data storage, and the different libraries that are being listed, which could be useful for the Kotlin multi-platform development. But there is still, because this technology kind of a bit of new, so there is still like a lot of development going on, and the ecosystem is getting bigger and bigger day by day. So now let's talk about the Compose multi-platform. So uh, we have Compose on Android side. So what JetBrains did, that they picked that Android Compose, and converted that into multi-platform. Now that specific, which just some tuning, etc. So now that JetBrains, the Android Compose runs on different platforms. So which is called Compose Multi-Platform, and basically Compose Multi-Platform is the clone of the Android Compose. So this is an application that I developed with the Compose multi-platform, just a simple circular pillable loader. So it is same like doing the Android development. So in this case, what you will have that like you can write your composable code inside your common main, and based on that you can call that. So here we have the app, and then we have material theme, and then we have like just a button. Based on the click, we are showing and making visible invisible in image. So this is how you can write the Compose multi-platform uh, code, and it is like kind of same as we have the in Android. So here you can see that we have an f function which is in the common main, and we are calling that from the main activity, and it is being called as a Compose. And then this is how like the setup of the Compose multi-platform on Android is very straightforward. Like you just call the app which is in the common main, and you are done. But in case of the iOS side, so you have to create a controller. So we have a main view controller, and which should be like which is a wrapper, which is kind of a wrapper view. And inside that controller we have to call our composable. So here we have Compose UI view controller, which could render the Compose code. And then the main view controller, it is in the iOS shared in the iOS shared directory. And once we get that, then we have to just like call that. So here you can see that we have a Compose view, which is the Swift code. And then we are calling our main view controller dot kt dot main view controller. So our, because our function name was main view controller, so the auto generate added the kt with that, because this is the Kotlin file. So main view controller kt dot main view controller, so that is our function that we are calling. So this is how you can call the Compose multi-platform code from the Swift UI. And if you talk about the navigation, so there are different navigation libraries that are available in the Compose multi-platform. So we have Decompose, we have Voyager, we have Compose navigation. So recently, the Compose navigation have also added support for the Compose multi-platform. So we have Compose navigation, and we also got the support for the shared element transaction in Compose multi-platform. So nowadays, like you can think of developing a multi-platform application same as like a Compose Android application, because a lot of libraries are supporting KMP now. So we have view model that now supports KMP. We have data store, we have room, we have lifecycle, we have pagination, and a lot of other Android libraries. So they are adding support for the KMP. Now that was about the ecosystem and related to the like how you can get started with. Now let's talk about the IDEs. So the main IDE is the Fleet, but which could it's like a polyglot library which can compile and can help you in reading different kind of codes, not just like Kotlin or some specific one. So we have Fleet in which you can navigate between the Swift code, the Kotlin code, and it will provide you to deploy your application for Android, iOS, web, and desktop. Then we have Android Studio. So that is the main ID I use for the Kotlin multi-platform development. Then we have Xcode. So sometimes like you have to use Xcode, uh, and then we have IntelliJ IDE. So for the web and desktop, so we have to use the IntelliJ IDE. So it's a mix of IDEs that you need to use, but the main one is the Fleet, which will help you to deploy your application across multi-platform like Android, iOS, web, and desktop. So that was related to the IDEs, and now just like a bit of comparison. So that comparison is very old, which is done by the Jacob Ross. So when that comparison between the size of the native and the KMP was done. So in that case, we have the Kotlin 1.6 and the KMP was 1.4.0. So the latest version of the KMP is 1.6, something that is stable, and we have 1.7 also alpha versions available, and the Kotlin latest version is like 2.0 point something. So that was like just a bit of comparison. So if we look into the Android, in case of the native Compose and Swift UI, so we have 1.4 MB of the Android, and on the iOS side the native application size was 1.7 MB. But in case of the KMP, so 1.63. Why the size of the KMP and the native is same? Because we have a Skia which is like already built in the Android. So in the Kotlin, so they are same to same, but on the iOS side you will see that the size has been like a bit high. It's like around 2432 MB, because we have to bundle the Skia also with the deployable, and then we have the Flutter comparison. So the Flutter size was 6.8 MB and 17.9 on the iOS. So that is like a very old comparison, but like just to have give you a overview. And then we have the startup size. So on Android, so it is like pretty much same to same, and same is on the iOS. So a native iOS is taking 1.4 second to launch, but the KMP is taking 1.6 seconds. So it's like almost same to same, and there is a lot of improvements that have been done into the Kotlin and to the Kotlin Compose and Kotlin multi-platform. So that was it about this session. So now, if you have any question, so I would love to answer that.
Thank you, Abdul Basit, for your fantastic session today.
Mm.
Your presentation was very informative. And now let's take a look at the comments.
Yeah.
And we have a question from Malik. In the context of developing for iOS, how does KMB compare to Flutter React Native? I think you just covered that. Do you have anything to say?
Yeah, so the in the context of developing for iOS, how does KMP compare to Flutter React Native in terms of the performance? So I think in terms of performance, so that is really good. Like basically, I think I was looking into some other comparisons. So it is like performing better than the the Swift, because the I think the Kotlin pre-compiles or something like that. So just-in-time compilation is something related to that, but it also have garbage collection. So it like runs very fast, but it also kind of because the heating system, so it takes like much more memory as compared to the Swift UI. But overall, in my experience, I think it works really well on the iOS side. Yeah, but I can share that comparison with you.
Okay. We have seen many popular apps built with Flutter. Do you have the same with KMB?
Hmm. So the KMP is like still gaining the ground, but if you look into the Kotlin multi-platform page, so we have like a lot of applications that are developing. So I think Philip is using that, McDonald's is using that. I think Alibaba, or there was some other vendor that was using that. So there is like a lot of people who are experimenting with that. Kareem is using KMP, I think, with some specific logic for their logic part. So I think it is still gaining traction, and applications are being developed with the KMP. And we have also the Bazaar application here in Pakistan. So it's also being developed on the KMP, and I think they have like a lot of users, and it is performing really well.
Okay, great. We have another one. Is it possible to have the data and business layer in a separate repository from the UI layer for each platform in KMP? And do you recommend this approach over having everything in one repo?
Yeah, so that is totally possible that you can have like your data and business layer in separate repository. So I will give you an example. So in Sadapi, so we were using the KMP for our analytics. So because we have discrepancy between the Android and iOS, so we thought why not like use KMP for that, so that we can have um, mm, similar names for the event. Like sometimes there is like an event, so the E is capital or small, right? So these kind of discrepancies happen. So we did that, and we publish it is in separate repository, and we publish the artifacts into the is a cocoa part, and also into the uh, AAR library dependency, and then these are being pulled. So this is how we are doing that. But I think it depends on your organization, how your organization is structured. So if you have like a squad kind of setup, so in that case, the multiple repo would make sense. Or like if you have micro front end kind of thing, so you can have also different modules inside your same repo, and based on that, like you can do things. So but that is possible. Like you can have like either one repo or multiple repos. But I would prefer one repo, because sometimes it's like get a bit of difficulty to have like syncing and these things. So you can also have one repo, but again that depends on like how your organization is structured.
Okay, great. And this is a follow-up question, which how can we manage updates and artifact in this setup?
Yeah, so like if you want to publish multiple artifacts, so it is same like as you do for the Android and iOS. So you can build create a new deployment or new artifact, publish those, and then you can pull those artifacts via some dependency management system and bump their version. But I think with the CI/CD, so if you are trying to do the CI/CD, so you might have some difficulties because on uh, there it is still in development, right? So there is like still a bit of leakage. So for the CI/CD setup, so you might struggle a bit, or like you have to dig a more bit, but that is possible.
Okay, great.
I hope this answers. I do not think so that after launching CV is also becoming this with hybrid application development. Yes, I think it is happening, and like recently with the Flutter, and with the because I see that they are putting a lot of effort now in the KMP, in the CMP. So you one example is the shared element transactions. So they were missing for a very long time, but now they have added that. So I think maybe like we still have to see how we can see that. But in the it is also like uh, becoming a competitor to the Flutter and React Native, because now we have the CMP, KMP. So with that, we can develop a full-fledged app targeting multiple platforms.
Okay. Flutter and KMP both are good. Can we suggest any real scenarios on which we can choose any one?
Yeah, interesting question. So basically, I have not myself worked with the Flutter, but if you try to invoke the native API, so I think it is a bit difficult. But as I have worked with KMP, so in that case it is really easy. Like recently I was integrating the AWS SDK, the cognitive SDK, into the KMP application. So integrating that, it was really easy, because you can create an interface and provide implementation on different platform, and then as an entry point you can provide that interface, and then you can call that. So it is a kind of really easy. And you can also touch where you can also touch the native APIs uh, very, I would say, very easily. So but I think there was recently an article released by the Google. So they were saying if you are targeting if if you're targeting like a full-fledged application. So for that, you should like the UI, the logic, and everything should be shared. So in that case, the like Flutter is the best choice. And in other scenarios, you should choose KMP.
Okay. And our final question, is there an official project or template for Gradle or Maven archetype for creating a KMP project?
Yes, so there are multiple. So I think I shared 2 to 3 templates. They were all official, and you can also start with the in the Android Studio. So go there and integrate the KMM plugin, and then go to File and create a new project. So there you will see 2 new templates that are available to you: Kotlin Multiplatform app and library.
Okay, one final question. Is KMP ready for production use? I think we all have
Ah,
this.
yeah. So if you talk about, if you look into the KMP, so it is stable on the desktop and Android. But for the iOS, I think it is still in alpha or beta. But I think it's is going really well, and they are investing in that. So I would say it will be soon production ready. And for the support for the Vism and the web, it is still in, I think, in experimental phase or something like that. So it's still not like production ready, but kind of you say that you can try that and the result will be good.
Yeah, and I would like to add something here that I am currently working in an environment where we have a KMP production already,
Mm.
and our production app is made by KMP for both
Oh, nice.
Android, iOS, and the web platforms.
Amazing, amazing. So
Yeah,
how's like your experience with like how's the feedback and
everything is going great. It's just native, nothing.
yeah,
Yeah,
yeah, it's really good. Yeah.
yeah. Maybe we can take about that later because we are already out of time.
uh,
So
yeah,
thank you, Abdul Basit, for your
thank
insightful
you,
and informative presentation. That was exceptionally well delivered.
thank you.
And before we conclude, we want to remind you, everyone, that we have our next session, which is it worked on my iPhone 15 Pro Max. And we hope to see you there. Have a great day and see you in the next session. Thank you, Abdul Basit. Have a
Thank
great day.
you.
Bye bye.